students, I hope all of you are doing good. Let's start today's chapter, Exponents. There are many occasions when we have to multiply a number by itself several times. For example, to find the volume of a cube of sides 3 centimeter, we multiply 3 by itself 3 times. Okay, so volume is equals to 3 centimeter into 3 centimeter into 3 centimeter. We can express such multiplication in the exponential notation or power notation. In this form, we express volume as 3 raised to the power 3 centimeter cube. This is the unit of volume. Okay, here the 3 to be multiplied is called the base. Okay, this is base. Okay, and the number of times it is multiplied itself is called the exponent, means this is exponent. Okay, and it is called index. It is also called index or power, means we can also call it power or index. The table below gives some examples of total rational numbers are written in exponential form. Okay, see, this is the product exponential form, and we read it as 2 by 3 raised 2 by 3 raised to the power of power 2, or 2 by 3 squared. Okay, 1 by 3, how do we read it? 1 by 3 raised to the power 3, or 1 by 3 cubed. Okay, this is minus 1 by 2 raised to the power 4, and this is minus 1 by 4 raised to the power 5. Okay, so using the definition of multiplication of rational numbers, we can write as 1 by 2 square is equals to 1 by 2 into 1 by 2, right? Or you can also write it as 1 square upon 2 square. Okay, now generalizing this, what we can say this, p by q raised to the power m is equals to p into q, p by q into m times, okay, p raised to the power m upon q raised to the power m. Okay, thus for a rational number p by q and for a positive integer m, for a positive integer, here we are saying we have p by q raised to the power m, or you can also write p raised to the power m and q raised to the power m. So using this relationship, we can express a given power of a rational number as a rational number and vice versa. Okay, let's do the example. Example number 1. In this, we have to express the following as rational numbers. Okay, 3 by 4 raised to the power 5. Okay, so how are you going to write it? You can also write it like 3 raised to the power 5 upon 4 raised to the power 5. That means 3 into 3 into 3 into 3 into 3, and 4 into 4 into 4 into 4 into 4, 5 times. Okay, now you can multiply them and write the answer. Okay, exercise 6.1, express as a rational number p by q. Okay, 3 by 5 raised to the power 3. So how will you write it? 3 raised to the power 3 upon 5 raised to the power 3, or 3 into 3 into 3 upon 5 into 5 into 5. 3 into 3, 9. 9 into 3 is what? 27. 5 into 5, 25. And 25 into 5 is 125. Okay, so this is your answer. Laws of exponents, positive exponents. The laws of exponents on integers can be extended to rational numbers too. For any rational number a and positive integers m and n, we have the following laws. Law 1 is a raised to the power m into a raised to the power n is equals to a raised to the power m plus n, means when bases are same, we, in case of multiplication, we will add the powers or exponents, right? Let us consider one example. 2 by 3 raised to the power 3 into 2 raised to the power 2 by 3 raised to the power 5. Okay, so what will you do it? See, bases are same, 2 by 3, we will just add the powers. Okay, so 2 by 3 raised to the power 8. This is the answer, right? Law number 2. If a is a non-zero rational number and m and n are positive integers such that m is greater than n, then a divided by a raised to the power m divided by a raised to the power n is what? This time bases are again equal, but there is a sign of division. Now we will subtract the power, that is a raised to the power m minus 1. Okay, let's do the example, only then we will get to know about this. Okay, so this is the example. 2 by 3 raised to the power 5 divided by 2 by 3 raised to the power 2. Okay, 2 by 3, bases are same, 2 by 3. There is a sign of division, we will minus or subtract the power. So, we will get 2 by 3 raised to the power 3. Okay. Law 3. If A is a non-zero rational number and M and N are positive integers such that M is less than N, then A raised to the power M divided by A raised to the power N is equals to 1 by A raised to the power N minus M. Okay. So, this, what does this law say? That A raised to the power M divided by A raised to the power N is equals to 1 by A raised to the power N minus M. Here M is less than N. Okay. So, what will you do? See, 3 by 4 raised to the power 3 divided by 3 by 4 raised to the power 5. Okay. So, in this case, you will apply this rule. 1 upon A, that is 3 by 4 raised to the power 3 N minus M. Okay, this is N minus M. N minus M, that is 5 minus 3. So, 1 by 3 raised to the power is what? 2. Okay. Next, law 4. If A is any non-zero rational number and M and N are positive integers, then A raised to the power M raised to the power N is equals to A raised to the power Mn. Means we will multiply both the exponents. Okay. So, for example, we have this example, 3 raised to the power 2 raised to the power 3. Okay. So, what will you do? We will multiply these exponents. 3 raised to the power 2 into 3 is 6, right? Exercise 6.2. Fill in the blanks. 2 raised to the power 2 into 2 raised to the power 5 is equals to 2 raised to the power how much? So, we will add these two powers, that is 4 plus 5, that is 2 raised to the power 9 is the answer. Okay. Next, laws of exponents applied to negative exponents. The rules of multiplication and division that apply to positive exponents also apply to negative exponents. The numbers that we get by raising integers to negative exponents are not in fact integers but rational numbers. We denote the reciprocal of a rational number p by q by this symbol, p by q raised to the power minus 1. Okay. It is written as a raised to the exponent minus 1. In a similar manner, we say that 3 raised to the power minus 2 is the reciprocal of 3 raised to the power 2 and minus 9 raised to the power 4 is the reciprocal of minus 9 raised to the power 4. Okay. So, x raised to the power minus m is the reciprocal of what? X raised to the power m. So, that is 3 raised to the power minus 2 is what? 1 by 3 raised to the power 2. Okay. Raised to minus 9 raised to the power minus 4 is 1 by minus 9 raised to the power 4. Okay. Also, x raised to the power minus m is equals to 1 by x raised to the power m, x being a non-zero integer. This meaning can now be applied to rational numbers. Thus, we have 3 by 5 raised to the power minus 3 and reciprocal of 3 by 5 raised to the power 3. Okay. So, reciprocal of 3 raised to the power 3 upon 5 raised to the power 3 is equals to 5 raised to the power 3 upon 3 raised to the power 3, that is 5 by 3 raised to the power 3. Okay. Similarly, minus 11 by 13 raised to the power minus 7 is equals to the reciprocal of this. Okay, that is 13 by minus 11 raised to the power 7. Okay. Next, law 1. If A is a non-zero rational number and M is a positive integer, then A raised to the power minus M is the reciprocal of A raised to the power M. That is, A raised to the power M is equals to 1 by A M. Okay, let's do the example. Example number 1. Find the value of 3 by 4 raised to the power 5. Okay, we will do the reciprocal of this. So, 4 by 3 raised to the power 5. Okay, now you can find the answer of this. You have to, because you have to find the value. So you will write it as like 4 into 4 into 4 into 4 into 4 5 times. And you will also write 3 5 times. Okay, then you will get this answer. Next, law 2. What does it say? If x is a non-zero rational number and m and n are any integers, positive or negative, then x raised to the power m into x raised to the power n is equals to x raised to the power m plus n, about which we have already studied. Okay, let's do the example. Okay, so we have to show that 4 raised to the power 5 into 4 raised to the power minus 3 is equals to 4 raised to the power 5 plus minus 3. Okay, so first we will take this side, that is LHS. 4 raised to the power 5 into, we will do reciprocal of this, 1 by 4 raised to the power 3. Okay, so 4 into 4 into 4 into 4 into 4 5 times, and 4 into 4 into 4, 1 2 3 1 2 3. So 4 raised to the power 2. Okay, next as RHS. RHS is what? 4 raised to the power 5 plus minus 3. So 4 raised to the power 5 minus 3 is what? 4 raised to the power 2. See, this is LHS, this is LHS, and this is RHS. Both are equal. Okay. Next, law number 3. If x is a non-zero rational number and m and n are any integer, then x raised to the power m raised to the power n is equal to x raised to the power m into n. For example, 2 by 3 raised to the power minus 3 raised to the power 4. So we will write it as 2 by 3 minus 3 raised to the power minus 3 into 4. Okay. Law number 4. If x and y are non-zero rational numbers and m is any integer, then x into y raised to the power m is equals to x raised to the power m into y raised to the power m. Okay. For example, we have to show that 7 by 8 into 5 by 7 raised to the power 3 is equals to 7 by 8 raised to the power 3 into 5 by 7 raised to the power 3. Okay, so what is the solution? First, we will take LHS. Okay, 7 by 8 into 5 by 7 raised to the power 3. Okay, we are taking here. We can also write this like this: 7 raised to the power 3 upon 8 raised to the power 3 into 5 raised to the power 3 upon 7 raised to the power 3, or 7 by 8 raised to the power 3 into 5 by 7 raised to the power 3. Now just have a look. That is LHS is equals to RHS, right? So we have showed it. Okay. Next, zero exponent. If a is a non-zero rational number, then a raised to the power 0 is equals to 1. Consider an example: 3 raised to the power 2 into 3 raised to the power minus 2. So we will write it as 3 raised to the power 2 minus 2. Okay, so we will get 3 raised to the power 0. Okay, or you can also write it like 3 raised to the power 2 into 1 by 3 raised to the power 2. Okay, 3 raised to the power 2 and 3 raised to the power 2 goes cancel, and we get the answer 1. That is why 3 raised to the power 0 is equals to 1. Right. Exercise 6.3. Find the value of 3 raised to the power minus 4. We have to find the value. 3 raised to the power minus 4. We will do reciprocal of this. 1 by 3 raised to the power 4. So 1 by 3 into 3 into 3 into 3. 3 3s are 9. 3 3s are 9, and 9 9s are 81. So 1 by 81 is the answer. Okay. Scientific notation or standard form of notation. In many situations, we come across numbers which are very large. For example, the speed of light in vacuum is approximately this much. That is 30 crore meter per second. Similarly, the age of our universe is approximate this yours. The mass of Earth is calculated as that much metric tons. In such cases, usually we write these numbers using exponents with base 10. This way of expressing values is often known as scientific notation or the standard form of a number. Working rule: What does it say? In order to write a very large number or a very small number, we use the form k into 10 raised to the power n, where k is a terminating decimal such that 1 is less than or equals to k, or k is less than 10 and n is an integer. Thus, the speed of light is what? Is written as 3 into 10 raised to the power 8 meter per second. Similarly, age of our universe can be written as 8 into 10 raised to the power 9 years, and mass of the earth is 5.98 into 10 raised to the power 21 metric tons, or as 5.98 into 10 raised to the power 24 kg. Exponents help us to express very small values too, but then the value of n is negative. For example, the unit of wavelength is 1 angstrom, which is this of a meter. So we can express this as 1 into 10 raised to the power minus 10 meter. Similarly, a number, this can be written as 4.5 into 10 raised to the power minus 8. Okay. Now, procedure to write numbers in scientific notation. It is easy to write a number in the standard scientific notation if you follow the following procedure. Number 1, number expressed in scientific notation should have the decimal point after the first non-zero digit. 2, the number of places the decimal point has to be moved determines the exponent of 10. 3, if the decimal point has to be moved from right to left, okay, remember this, if the decimal point has to move from right to left, the exponent is positive. And number 4, very important, if the decimal point has to be moved from left to right, the exponent is negative. Okay, so these two things keep in our mind. Okay, now express the following the scientific notation. Okay, 5, 7, and then how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the decimal point has to be moved 10 times to the left. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will write it as 5.7 into 10 raised to the power 10. Okay. Let's do exercise 6.4. Express the following in a scientific notation. Okay, so let's do the second one. Okay, 0.0000. How many zeros are there? 4, and then 5, 3, 2. Okay, we have to move this decimal after 5. Okay, and we are moving from where? Left to right. So in this case, what is the the exponent will be the negative. Okay, 1, 2, 3, 4, 5. Okay, so 5.32 into 10 raised to the power minus 5. Okay. Things to remember. Number 1, a number x multiplied by itself m times can be expressed in exponential notation as m raised to the power minus m. Here x is the base and m is the exponent or index or power. If x is equals to p by q is a rational number and m is a positive integer, then x raised to the power m is equals to p raised to the power m upon q raised to the power m. 3, if a is a rational number and m and n are integers, positive or negative, then we have these 3 rules. Okay, for any non-zero rational number a raised to the power 0 is equals to 1. 5, if x and y are non-zero rational numbers and m is an integer, then x into y raised to the power m is equals to x raised to the power m into y raised to the power m. And 6, a number is written in the scientific notation or a standard form as k into 10 raised to the power n, where k is a terminating decimal such that 1 is less than or equal to k, or k is less than 10 and n is an integer. Okay, students, I hope you have understood this chapter. Now you will do practice of this chapter.